When a metallic conduit is connected to an aluminum cable tray, metallic bonding is essential to ensure electrical continuity and safety. The objective of metallic bonding is to create a low impedance path for fault currents, facilitating the operation of overcurrent protection devices and minimizing the risk of electrical shock. When dealing with dissimilar metals like steel conduit and aluminum cable trays, galvanic corrosion is a potential concern. Galvanic corrosion occurs when two dissimilar metals are in electrical contact in the presence of an electrolyte, such as moisture. The less noble metal corrodes preferentially. In this scenario, aluminum is more anodic than steel, meaning it is more prone to corrosion when in contact with steel in a corrosive environment. To mitigate galvanic corrosion, several methods can be employed. Firstly, use compatible fittings designed for connecting dissimilar metals. These fittings often incorporate a non-conductive barrier to prevent direct contact between the steel and aluminum. Secondly, apply a corrosion-inhibiting compound to the contact surfaces before assembly. These compounds create a protective layer that minimizes the risk of galvanic corrosion. Thirdly, ensure proper sealing to prevent moisture from entering the connection point. Moisture acts as an electrolyte, accelerating the corrosion process. Fourthly, consider using stainless steel hardware for connections, as stainless steel is more galvanically compatible with aluminum. The installation should comply with the National Electrical Code, or NEC, which provides guidelines for bonding and grounding. Section 250.92 of the NEC covers bonding requirements for metal enclosures and raceways. It mandates that metal enclosures and raceways be metallically joined together to form a continuous electrical path. Section 250.96 addresses bonding of enclosures containing service conductors. It specifies that enclosures containing service conductors be bonded in accordance with Section 250.92. Section 250.97 pertains to bonding metal enclosures to grounding electrode conductors. It requires that metal enclosures be bonded to the grounding electrode conductor to provide a low impedance path to ground. Regarding the use of locknuts and bushings, standard locknuts and bushings may not provide adequate bonding for this application. While they can mechanically secure the conduit to the cable tray, they may not establish a reliable electrical connection, especially considering the potential for corrosion and loosening over time. The NEC requires more robust bonding methods. Acceptable bonding methods include using bonding bushings with a grounding jumper, grounding locknuts with a grounding lug, or exothermic welding. Bonding bushings are equipped with a sharp edge designed to bite into the metal enclosure, providing a secure electrical connection. They also feature a terminal for connecting a grounding jumper, which is then connected to the cable tray. Grounding locknuts are similar to standard locknuts but have a grounding lug for attaching a grounding conductor. Exothermic welding involves creating a permanent metallurgical bond between the conduit and the cable tray, offering the most reliable electrical connection. When punching a hole in the side of the cable tray, ensure that the hole is clean and free of burrs. Burrs can interfere with the bonding connection and increase the risk of corrosion. After making the connection, inspect it thoroughly to ensure that it is mechanically and electrically sound. Use a multimeter to verify the continuity of the bonding connection. The resistance between the conduit and the cable tray should be very low, ideally less than 1 ohm. Regularly inspect the bonding connections for signs of corrosion or loosening. If corrosion is present, clean the affected area and reapply a corrosion-inhibiting compound. If the connection is loose, tighten the hardware or replace it if necessary. Proper bonding is crucial for the safety and reliability of electrical systems. Failure to bond properly can result in electrical shock, equipment damage, and fire hazards. In summary, when attaching a metallic conduit to an aluminum cable tray, metallic bonding is required. Standard locknuts and bushings may not provide adequate bonding. Use bonding bushings with a grounding jumper, grounding locknuts with a grounding lug, or exothermic welding to ensure a reliable electrical connection. Mitigate galvanic corrosion by using compatible fittings, applying a corrosion-inhibiting compound, ensuring proper sealing, and using stainless steel hardware. comply with the NEC guidelines for bonding and grounding to ensure the safety and reliability of the electrical system.